Okay, hello everyone. In the previous videos on Simplex, we have done Simplex method on two variable LPP. We have seen the logic as well as the steps that are involved. Now in this video, we are going to look at Simplex method, which we use for a three variable. It's just one and the same, just a bit of more calculations will be involved. Otherwise, the overall procedure remains the same as we have seen in the two variable Simplex. So in this video, we're going to concentrate on how do we solve this three variable simplex, and it will be just a sort of practice or repetition of the steps that we have done in the generic simplex method. So to save our time, what we have done is I have taken this question. I've taken this question and also have converted that into a simplex compatible by simply adding the slack variables, and these slack variables are S1, S2, S3, and the coefficients in the objective function will be 0. The logic for this we have discussed in the previous videos. Now let's go ahead with the first simplex table that we are going to form out of this LPP. So let me just name it as simplex table 1. So in this simplex table, the columns are going to be the same. We have fixed ratio, program, profit, quantity. Then we're going to have x1, x2, x3, s1, s2, s3, and then last column of replacement ratio. As we have seen in the previous table as well as in the previous videos, we always start with the slack variables s1, s2, and s3, assuming that all our resources are idle. So s1, s2, and s3. We know the profits on these idle resources as of now it is 0. Quantity, well, we know that in the first simplex table, all the resources are idle. Therefore, it's going to be this number 400, 200, and 300. So that's 400, 200, and 300. Post that, we have to fill up this main body of the table, and we know these numbers are simply the sacrifice ratio between the program variable and the column heading variable. And we know that these numbers can be simply filled up as coefficients from my constraints. So we're going to write here 2, 8, 2, 1, 0, 0. So that's going to be 2, 8, 2, 1, 0, 0. Same way for the second one. That's 1, 1, 4, 0, 1, 0. And the last one is 1, 0, 1, 0, 0, 1. Okay, so that's the main body of the table. Then starting with the decision making, we know CJ. CJ is the the gross benefit. It's written as the coefficients of the objective function value. So that's 140, 300, 400, 0, 0, 0. Then we write ZJ. ZJ, we know it is opportunity cost, and that opportunity cost is simply the profit multiplied by the sacrifice ratio and then adding up all of them. So that's going to be 2 into 0, 0, and 0. We know everything, it's going to be 0. In the first simplex table, in case of maximization, we know that it's going to be 0 because there is no opportunity cost. So therefore, we see opportunity cost as 0. And then finally, we have CJ minus ZJ. We have CJ minus ZJ, which is 140, 300, 400, 0, 0, and 0. Then out of these three, which one do we select? We select the best positive or the highest positive number since it's a maximization problem. Since this is a maximization problem, obviously the choice for us is going to be the highest positive. So we select this, and we know that this column is marked as key column. Then in this key column, we go for the next step where this number or 400 tells us that we should produce x3. But how much quantity of X3 to be produced? That will be done by the replacement ratio, and that replacement ratio is going to be simply 400 divided by 2, which is 200. Then 200 divided by 4, that's 50. And 300 divided by 1, that's 300. Okay, so in this way we have the replacement ratios. And if you could just recollect, out of these replacement ratios, which one do we select? That is, we know that X3 is to be produced, but how much units am I going to produce? 250 or 300? Obviously, the choice is to go for the lowest positive, and therefore we mark this particular row as key row. Then we come to the next stage of fixed ratio. In the fixed ratio, we know that the calculation of fixed ratio is simply the number divided by the intersection. So over here, the key column number 2 divided by 4. So our fixed ratio is going to be half, this one on, and then the last is also going to be 1 by 4. That's simply 1 by 4. 1 divided by 4. Okay. Along with that, we decide which is our incoming variable and which is our outgoing variable. Incoming variable, we know it is always the key column. So the incoming variable is X3, and outgoing variable is always the key row, which is S2. So that is simplex table 1. So here in the simplex table 1, we concluded that we should produce some units of X3. Now, how much units of X3? That also we have decided, 50 units. And that we are going to demonstrate in the next table, whether by producing 50 units of X3, am I reaching the optimality? So here we go for the next table, and let me name it as simplex table 2. So here again we say fixed ratio, program, profit, quantity, x1, x2, x3, s1, s2, s3, and replacement ratio. Then, as we have decided, in this program column, S1 is continued to be there, S3 will continue to be there, but in place of S2, we are going to get X3. So we have X3 over here. Then talking about profits, that's 0 and 0. X3 is giving us a profit of 400. Then regarding filling up the values over here now. So we have 3 rows to fill up. And out of these 3 rows, talking about the row which was earlier a key row. So the middle row, this row, was the key row earlier. And we know that in order to fill the key row, what we simply do is we simply divide the old values by their intersection. So old values by their intersection, this will be 200 divided by 4, 1 divided by 4, again 1 divided by 4. So let us just quickly write down those numbers in our table. So we have 200 divided by 4, which is 50. Then the other is 1 by 4. Then it is 1 by 4, 0. Okay, x3 will be 1, 0, 1 by 4, and then 0. Then with regards to the other two rows, S1 and S3, with regards to the other two rows, S1 and S3, S1, we need to fill it up on S3 also needs to be filled up by the working. And we know the working that takes place. The working is simply A minus B, which we have seen in the previous videos also. So let's do the working. So this working is going to be for S1. For S1, it is going to be A, B, and then A minus B. Same way, we will have the working for S2 as A, B, and then A minus B. So the working for S1, A, we know it is the old values. So let's quickly write down S1 ka old values. So S1 old values are this 400, 282, 100. So the old values are 400, 282, 100. These are the old values. And then after this, once we are done with this 400, 282, 100. Next we go for B, where B is simply the key row multiplied by the fixed ratio. So this is the key row multiplied by S1 ka fixed ratio. So that's going to be 200 multiplied by half, 1 multiplied by half, again 1 multiplied by half. So we do that calculation and write down the B values, where we get the B values as 200 into half, which is 100. Then we have half, again we have half, 2, then we've got 0 into half, so that's 0, then half into 1, so that's 1, and then 0 into half is again 0. So we've got A minus B values as 300, 3 by 2, so that's 8 minus half, which is 15 by 2, 15 by 2. Then we have got 0, 1, minus 1, and 0. So let us quickly write down these S1 values over here. So we say that's 300, 3 by 2, 15 by 2, 0, 1, minus 1, 0. Then talking of working for S3 now. So working for S3, we first write down the old values. S3 old values are 300. S3 old values are 300, 101, 101, and then B values. B is simply the key row multiplied by fixed ratio. So 200 multiplied by 1 by 4. So that's basically 50. Then next is 1 multiplied by 1 by 4. So that's 1 by 4. Again 1 by 4. Again 1, 0, 1 by 4, and 0. And then do the A minus B 250. 1 minus 1 by 4. That's basically 3 by 4 minus 1 by 4, 0, 0, minus 1 by 4, and 1. These are A minus B values. Let's write down these A minus B values over here now. 250, 3 by 4, minus 1 by 4, 0, 0, minus 1 by 4, and 1. Then we have the CJ values, which is the gross benefit. So that's 140, 300, 400, 0, 0, 0. That's the CJ values remaining constant every time. Now, after CJ, we need to write down the ZJ values. Now, ZJ values are simply the profit multiplied by the sacrifice ratios. So the ZJ values we've got here as 100, which is 0 into 3 by 2 plus 400 into 1 by 4 plus 0 into 3 by 4. Then the other one is 100. You can say this to be 400. Then this is 0. The other one is over here, 0 into -1. There seems to be some mistake over here. Yeah, for the b value, it should be half into 1, correct? So this should be 1 by 2 and -1 by 2. So even here we are going to have -1 by 2. Okay, if we simply do that, okay, after that, if we look at it, we get this to be S1 into, or 0 into minus half, 400 into 1 by 4, 0 into -1 by 4. So basically that's 100, which is 400 into 1 by 4. And then this is going to be 0. Then we have Cj minus Zj values, which is 40. Then 200, 0, 0, -100 and 0. And we know here that we are going to select this one, 200, because it's the highest one. So 200 is selected, and then this is marked as key column. Then we are going to calculate the replacement ratio, which is quantity divided by x2, 300 divided by 15 by 2. So 300 divided by 15 by 2 is 40. That's 40. Then the next is 400 divided by 1 by 4. 400 divided by 1 by 4. So you should take it as a divide by 1 by 4. That is actually 400 into 4. So that's 1600. Oh, my bad. It's not 400, 200. Okay. So 50 divided by 1 by 4. So 50 divided by 1 by 4. 50 into 4, that's 200. And then finally, we got a negative value over here, -1000. And out of these, as I told you, we select the lowest positive. So accordingly, the lowest positive is this. And this is fully marked as key row. Then coming to the fixed ratio, it's going to be 1. This one is going to be 1. Then the fixed ratio is going to be 1 by 4 by 15 by 2. 1 by 4 divided by 15 by 2. That will be 1 by 30. The other fixed ratio is -1 by 4. -1 by 4 divided by 15 by 2, which is -1 by 30. So that's the second simplex table, and we find that simplex table 2 is still not the final simplex table, but rather it can be further improved. So let's go for the third simplex table now, guys, where we're going to see whether the third simplex table gives me the optimal solution. So simplex table 3. So we look at simplex table 3. So again, the columns are going to be the remaining same. Fixed ratio, program, profit, quantity, x1, x2, x3, s1, s2, s3. And then obviously we have the replacement ratio. So third simplex table, I'll just write it down. So in the program column, as we have discussed in the previous table, in the program column, the incoming and outgoing variable. Incoming variable will be x2, outgoing variable will be s1. Incoming is x2, which is the key column. Outgoing is s1, which is the key row. So this needs to be understood, and accordingly, in the third simplex table, in the programs, we are going to have, or rather we are going to simply remove this s1. In its place x2 will come, and x3 and s3 will remain as it is. So in the program, we have x2 X3 and S3. The profits are going to be 300, 400 and 0, which are nothing but X2 and X3 ka profit as coefficients from the objective function. Then out of these three, this was the key row in the previous table. In the previous table, this was key row. So I can simply obtain the values by dividing all of them by 15 by 2. So I can obtain them by simply dividing by all of them by 15 by 2. So let me just divide by 2, divide by the number 15 by 2 throughout. And you can see that you get these values. You get 40, you get x1 as 1 by 5. This is 1, this is 0, 2 by 15. And that's minus 1 by 5. It's minus 1 by 15 it should be. Then finally it is 0. Then from x3 you have to perform that operation of a minus b, which is old value minus the key row into fixed ratio. So this is basically going to be 50 minus 30 into 1 by 30. 50 minus 30 into 1 by 30. This row value will be 1 by 4 minus 3 by 2 into 1 by 3. So you can carry out that working note and just verify your answers that you should be getting these values. 40, 1 by 5, 0, 1. This one, S1 will be, just check, S1 will be over here 0 minus 1 by 30. So that will be minus 1 by 30, correct? So that's minus 1 by 30. S2 is going to be 4 by 5 and S3 is 0. So S3 we got 0, then we have got quantity as 260. Just calculate this 260. Then the x1 value is going to be, let me just verify it once. That's 3 by 2. 3 by 2 minus, sorry, 3 by 4 minus 3 by 2 into minus 1 by 30. So that's basically going to be 3 by 4 plus 1 by 60. So that's 3 by 4 plus 1 by, you can say this to be that number 60. So that should give you x1 ka value as 4 upon 5. Then you should be having minus 1 by 2, 0, 1 by 30, minus 4 by 5, 0. Then we have got Cj, which is continues to be remaining same, 140. Then what was Cj for x2? It was 300, 400, 0, 0, 0. Then you calculate Z. You will find this to be 140, 300. See the J is simply the profit multiplied by these numbers. 300 into 1 by 5 plus 400 into 1 by 5 plus 0 into 4 by 5. So that's 140, 300, 400. Then we have this to be 30 by 3, 260 by 3. And then finally we have got the last one as there seems to be some error. This S3 should be, let me just check. S3 value is 1 minus, so that should be 1 only, correct? 1. So anyways, that's simply going to be 0 only. So we have Cj minus Zj values as 0, 0, 0, minus 30 by 3, minus 260 by 3, and the last one which we observe is 0. So basically what we say over here now is there is no positive number over here. So that means the table is optimal, and we can say the solution for this is x1 is 0, x2 is 40, and x3 is going to be also 40. We also have this S3 as a solution 260, which we know it indicates idle resource. So we're going to have 260 units of the third resource idle even at the optimum stage. So we have completed a 3-variable simplex problem. Now the next video is going to be dedicated towards minimization using simplex algorithm. So we've got 2 more videos in this series of simplex, where the next one is going to be the minimization one, and the last one is going to be some special properties where we will discuss about the degeneracy, infeasibility, and so on and so forth stuff. Okay, so let's stop here for the day and see you in the next video, everyone. Thank you for watching the video.